Hello everyone, we are Group 7 and today we'll be presenting about equilibrium and thermodynamic state by Josiah Willard Gibbs.
Josiah Willard Gibbs was born in New Haven, Connecticut. His father was an abolitionist who held a Mr. African, enabling them to testify and win their freedom in 1841. He educated at Hopkins School and entered Yale College at age 15. He continued as a graduate student at Yale Sheffield Scientific School. In 1863, he earned the first PhD in engineering in the US. He never married, preferred a quiet and scholarly lifestyle. He died at age 64, which was caused by intestinal obstruction.
Thermodynamic state foundation of Gibbs' work. He defined that equilibrium as the state where a system Gibbs free energy is minimized at constant temperature and pressure. At equilibrium, both reactions are happening at the same rate as the stated example. Thermodynamic state and Gibbs state space. Thermodynamic state is the macroscopic condition of a system defined by variables such as pressure, temperature, volume, and composition. It provides a complete description of a system at equilibrium, while Gibbs state space is an abstract multidimensional space where each point represents a unique thermodynamic state. It visualizes thermodynamic processes as paths or curves between states.
In 1873, Josiah Willard Gibbs published a method of geometrical representation of the thermodynamic properties of substances, introducing a 3D graphical model to represent all possible thermodynamic states of a substance. In this model, internal energy is plotted as a function of entropy and volume, where each point on the surface represents a unique thermodynamic state. The surface slopes have physical meaning. Along US corresponds to temperature and along the UV corresponds to negative pressure. As we show you this rotating 3D model, observe how changes in S and V shift the surface, illustrating thermodynamic processes as paths on the surface. Fun fact, the model you see here was later recreated in plaster by James Clerk Maxwell, spreading Gibbs' ideas across Europe.
Gibbs free energy. Gibbs free energy tells us whether the process is spontaneous, non-spontaneous, or equilibrium. If the value of Gibbs energy is negative or below zero, the process is spontaneous. But if the value of Gibbs energy is above zero or positive, then the process is non-spontaneous. The process is only in the equilibrium state if the value of Gibbs value is zero.
For the real-world application, Josiah Willard Gibbs has contributed to chemical reaction prediction. For example, in the production of ammonia, engineers choose moderate temperature and high pressure to make the delta G negative and maximize ammonia yield efficiently.
These are our references. Thank you for watching and listening.